Hello, ladies and gentlemen. Thank you for tuning in to our video presentation of the 2019 report card for the Southwest and Road Rivers. We certainly appreciate you taking the time out of your day to learn about what's going on with our waterways, and thankfully we have some good news to report. So without any further ado, let me share my screen here and put up the PowerPoint presentation that we've created to explain what happened in the rivers last year. So right here on our cover slide, if anyone's interested, is a tugboat, Captain Kenneth, based out of West River, but you can see the David Taylor Research Center in the background there. So they're cruising up into the Severn to render some assistance. Before we get to the grades, I wanted to let everybody know that we are currently in the middle of our online auction. It started this past Tuesday and will go till next Tuesday, so please do check us out on the web page and check out the items that are there for purchase to help you enjoy your quarantine and your lockdown. I also wanted to send special thanks to all of the volunteers that help us to collect these data that we base the report card on, to analyze it, to review our quality assurance project plan every year and make sure that it's up to date and helping us do this scientific work in as rigorous and robust a way as possible. So thanks especially to Marvin Solberg, Diane McBee, Dr. Wayne Martin, and Dr. Jenny Gunderson, our quality assurance officers, for all you do and all you do for us and for the rivers. So the big picture from 2019 was that things got better than they were in 2018. 2018, as many of you will remember, had record rainfall. 2019 had a bit of a drought, and with less polluted runoff flushing into the rivers, things improved. Scores of 4 or 5% improvement across the board. But the thing that was interesting to us as we crunched these numbers was that these rivers didn't really necessarily improve in the same way. For instance, the nutrient scores for the South River improved a good bit by double digits. But in the road and west, the biggest improvements came in terms of bottom temperature. And that was interesting to us because 2019 on average was not markedly cooler than 2018 was. It had a cooler September and October, which might have played into it, but also, as we mentioned earlier, the diminished runoff could have played a role since there were less hot asphalt parking lots getting washed off with rain and flushed into the rivers. So the rivers improved, but in different ways. And without any further ado, here's the chart that shows the various parameters we mentioned and that we monitor. So you can see rivers are all really solid on pH, bacteria, dissolved oxygen readings, doing fairly well. And bottom temperature, it's a C, holding steady there. But where we really need to improve, it seems, is in our water clarity and our underwater grasses. And these are two parameters that go hand in hand. You can't grow underwater grasses without clear water to allow the sunlight to penetrate and allow the underwater grasses to photosynthesize. They're plants just like terrestrial plants, and sunlight is vital to their flourishing. So, you know, there was a bit of improvement in clarity in the South River. The Road River held steady. The West River went down a little bit. And underwater grasses did come back last year, thankfully, but we're still a far, far cry from where we need to be. The goal for restoration of underwater grasses in the South River is over 400 acres. And as you can see, we were only able to scrape together 3.6 in 2019. So much effort is still needed to make sure that we can bring back our underwater grasses. They're so vital to the ecosystem for reasons that we'll talk more about in a little while. But C pluses across the board for all three rivers. So solid, but could certainly use some improvement. And we need to make sure that we're continuing to take all steps we can to diminish polluted runoff into our rivers. That's our major source of concern, is stormwater runoff in the West Road and South Rivers. And if we can keep that water cleaner, we should see the grasses come back. So we collect these data through a few different ways. The clarity data, temperature, dissolved oxygen, and pH is all collected by Arundel Rivers Federation staff from the 52 stations you can see on this map on the right side of the slide throughout the 3 rivers. The bacteria data is collected at 36 stations, also by Arundel Rivers Federation. The number of stations and the places that they go can change from year to year because it depends on community involvement, who it is that signs up for our program, Operation Clearwater. Many of you live in communities that will have gotten letters or email about that program in the past week. I encourage everybody who is interested in their beach or their community marina being monitored to reach out to me, and I will make sure that you can get enrolled in the program. And we will start collecting data just before Memorial Day weekend. The bacteria that we find out in the water that we monitor anyway is enterococci bacteria. The EPA has set a limit of 104 colony forming units per 100 milliliters. So we go around on Wednesdays and do the sampling, and we have it analyzed at the community college, and the data are then disseminated by Friday afternoon every week so that the residents who live in communities that have signed up for the program can make safe and informed decisions about their swimming or water contact for the coming weekend. Now, there are 3 stations that the Department of Natural Resources maintains, 1 in each river, and you can see these stacked triangles indicating the locations of those stations. And those are where we get our nutrient data, total nitrogen and total phosphorus data, and also our total suspended solids data to understand the picture with sediments in the river. And then last, but certainly not least, our submerged aquatic vegetation, our underwater grasses data, is collected by the Virginia Institute of Marine Science at William and Mary. And this map on the right side of this slide shows the flight paths that are taken by VIMS as it performs its aerial underwater grass surveys. And that's where we get the figures for underwater grasses. So while we're on that subject, you can see here by this graph that 2019 was a great year, especially in the South River. We also saw good return of grasses in the road. Unfortunately, the West went without. It's not mentioned on this slide, but there was also a bit of a thick bed of grass actually that developed behind Holland Point in Herring Bay. And as you can see, the 2019 figures for the South River are higher than they've been for over a decade. And here I want to show you a video I took of the underwater grasses in Glebe Bay on the South River. Please forgive my lack of cinematography skills. I'm working on getting better with the drone, so it's a little less herky-jerky. But as you can see, as the camera goes up and turns around, the beds of grass are pretty thick in places here, and you can also see how they can function as habitat for juvenile fish and crabs to evade predators. They perform photosynthesis, which puts oxygen into the water. They use up nutrients so that they don't cause algal blooms, and they diminish the force of waves and prevent wave action from eroding the shoreline so much. Now here in Glebe Bay, we think that we saw a big resurgence of grass because of a combination of factors. Pretty soon the video will end, and the peninsula in the frame at the end of the video is where we have completed a living shoreline project that I'll show another slide on later that will illustrate the point a little more clearly. But right there in the center, you can see the breakwaters offshore from the peninsula in the Turnbull Estates community. And that is preventing erosion from a large bluff that had been eroding several feet per year, and all of that sediment pouring into Glebe Bay. Also though, in Glebe Bay, we have our oyster sanctuary reef. So you can see here the green shading covers the underwater grasses that we just saw in the video. There is the lower living shoreline is the one that I was just speaking of in the Turnbull Estates community. And then the upper living shoreline is in the London Town community, which London Town built of its own volition. They've actually done almost a mile of living shorelines throughout the community. It's been, London Town's been a great partner over the years with all of our clean water initiatives. But we think that the underwater grasses were able to come back because we diminished the sediment coming off of the Turnbull Peninsula, but we also have an oyster sanctuary reef in the center of Glebe Bay that helps to filter pollution, the algae that cause algal blooms and block sunlight from underwater grasses, and also collect on the surface of underwater grasses called epiphytes. And that combination of factors, we think, is what's enabling the underwater grasses to proliferate here in Glebe Bay like they are. Here's another nice aerial picture of the Turnbull living shoreline. And I'd also like to point out here the close-up of the reef balls that were installed in this project. On the lower left of this photo, you can see the concrete structures known as reef balls that are for growing oysters. The oyster spat on shell are embedded into the concrete, and those reef balls will serve the same purpose as the more traditional rock structures that are used in living shorelines, which you can see in the middle of the peninsula and there at the very tip. But with the added benefit of providing more oysters for the water, which clarifies the water the same as the oysters on the reef do, and also provides habitat for other creatures that can hide out in these reef balls. So in addition to consuming algae and improving water clarity that way, the oyster's shells, being calcium carbonate, are basic, and they help to drive up, they help to drive up the pH in the system. This slide is a different slide talking about water clarity, where you can see on our Glebe Reef, the water clarity was an average of 0.75 versus 0.6 meters of depth in the rest of the river. Here's the slide that I started talking about the pH change. The average on the river is 7.5 pH, which is solid, a little bit more basic than neutral. But at Glebe Reef, where the oysters are, it's 8.29. And so that increase in pH is really important because the bay overall is acidifying. As more carbon dioxide is present in the atmosphere, it gets into the water and drives the pH down, which can be threatening to not just oysters, but any shellfish that build shells out of calcium carbonate. It makes it harder for them to stack that shell onto themselves and protect themselves from predators and disease. And so the presence of oysters driving up the pH in the water is an encouraging sign that we're hopeful that the more oysters get out there, the more chance we have to reverse this acidification trend. So we can't leave it all up to oysters. We have to pitch in ourselves and try to help fix the waters. And the best ways that we can do that, or some ways we can do that anyway, are to volunteer with groups like Arundel Rivers Federation. We're always eager to help coordinate people finding the SAV on the river. So we're going to be starting up that initiative, reaching out to potential volunteers this coming week. So if you'd like to get out on your canoe or your paddleboard or your kayak or any boat now that the boating restriction has been lifted and help us look for SAV, we'd love to help assign you a creek. Also, oyster gardening is an incredibly important way to contribute to clean water. You hang oysters off of your pier or your community pier or a marina where you might be able to get access, and they will clean the water 24/7 and help us to deliver cleaner water in our rivers. And if you're interested in any more of the scientific data we have, please check out our website. It is a dated link. It's southriverdata.org, but I want everybody in the Western Road watersheds to know that we also have data from the stations down in those rivers up there also, and you can learn more about what is going on in your backyard. So to circle back to the overall theme of general improvement in the rivers and its link to rainfall, I wanted to put up these figures to demonstrate the average levels of rainfall. From 2010 to 2017, we averaged about 40 inches here in Annapolis. But in 2018, that total was 56.7 inches, and in 2019, 25.4. So the amount of rainfall was cut in half, a little bit more than half, between 2018 and 2019. This rainfall pattern is expressed in this graph in another way. You can see the 2010 to 2017 average is the blue shading. The gray line, the higher line, is 2018's rainfall over time, and the blue line is 2019's. You can see the dramatic difference there. Less polluted stormwater means cleaner, happier rivers. Here are some of the headlines showing the difference in weather, and especially in September, our driest September on record. Usually in September, we get our fair share of thunderstorms, and it is going to be washing lots of hot water, hot, dirty water into the rivers, and we were spared a lot of that in 2019. So all of the creeks in the South River improved in health, but we wanted to put up this slide to demonstrate a couple of points. The first is, if you look at the map on the right-hand side, you can see that the water tends to get cleaner as you get closer and closer to the mouth of the river. That's because the pollution in our rivers is coming from the watershed. It's not coming from the bay. And as you go further and further up a creek, you're going to see dirtier and dirtier water. But I wanted to especially point up on the lower left, that little table that shows the most improved from 2019. And among those creeks are Church and Beards. And this is so encouraging for us at the Federation because we've focused a great deal of our restoration efforts in the watersheds of those two creeks. So it shows that work is having an impact and is building in the kind of resilience that we're going to need to have in our creek systems if we want them to be able to withstand the increasing frequency of intense storms that we're having as the climate changes. And Church and Beards were identified early on in the existence of the Federation's monitoring program as the most impaired, and therefore it made sense to focus our efforts there sort of as a triage, if you will. Like if you were treating a medical patient, you go to where the bleeding is worst and try to fix it. And we're pleased to see that we can build in some resilience into these systems. Now, it also shows, because this is a rate of change for just 1 year, how much stormwater and precipitation that drives stormwater will impact urbanized streams like Church or creeks that have lots of incised stream banks like Beards and a larger watershed. And there's plenty of impervious surfaces in the watershed for Beards Creek too. So these flashy kinds of places have a big impact in terms of the immediate consequences to a creek from a big rainfall event. And when the streams in the watershed of these creeks start to get deeply incised, they become a source of pollution in addition to being a vector for upstream pollution. And when they're breaking apart as stormwater flows through them, it's all the more important that we take time to and devote resources to patching up these broken streams so that they stop pouring sediment into the rivers. And this same phenomenon of water quality increasing towards the mouth of rivers, you can see by these examples in the road and these examples in the west. As you get deeper and deeper up the river and up the creeks, the water clarity and the water quality overall tends to diminish. Here's another graph that explains this. You can see through the center of the graph, the 0 line is the average creek score for the rivers. And this is for the Weston Road rivers. And those creeks that rise above the 0 line have better than average water quality for that parameter, and those that sink below have worse than average water quality for that parameter. So for instance, you look at the dissolved oxygen, you can tell that Ford's Creek, that orange one, has worse water quality than, for instance, Cadle Creek, Cadle being right out towards the mouth of the Road River. And same goes for temperature. Cadle Creek has a much better temperature score, and Ford's is dipping below that. So we just thought this was another interesting way to look at that phenomenon of water quality as it relates to the location of the station in the river. That's a pretty common phenomenon that we've understood for a while, but every time we go through the reams of data we collect during a monitoring season, and just to put that in perspective, we have 52 stations we monitor every week for 4 different parameters. So there are a lot of different things for a 7-month period. So there are a lot of different data points to consider. And every time we do this, we tease out a new thing that is surprising for us. And this year, what we noticed was a distinct difference between the total suspended solids concentrations in the West and Road rivers versus the South. We weren't sure what might be driving that, and so we wanted to pull data from the Severn also to check and see what its total suspended sediments concentrations were like. And you can see the top lines there, the gray and orange, that's the West and the Road respectively. And then on the bottom part of the graph, blue is the South and gold is the Severn. And the two different river systems, the two river systems track each other more closely between the Western Road and the Severn and South. And so this raised the question in our minds of what might be causing it. And we put together this general land use chart for the 4 rivers. And you can tell the Severn and South are much larger than the Road in the West. They have more impervious surfaces, roughly the same amounts of forests. The Road River has the most forests, thanks largely to our friends at the Smithsonian Environmental Research Center and their large forested property. And then the area with the biggest differences, besides impervious surfaces, is in agriculture. The Severn and South don't have a lot, which squares with the recollection of anyone familiar with Anne Arundel County. The northern part of the county doesn't have as much rural agrarian land as the southern part of the county does. And you see here that the West has almost 1/5 of its watershed in agriculture. And these differences in land use, we think, are probably part of the picture, at least, of what is causing the difference in total suspended solids. Another one that we're really interested in looking at is the differences of soil types. And there are certainly different soil types as you travel north to south in Anne Arundel County, and some are more erodible than others. And a final piece of the puzzle that we think bears some consideration is that the Severn and South rivers have many more miles of non-tidal freshwater streams feeding them than do the Road and West rivers. And you can tell, looking at the total area of the watershed, the Road and West rivers have such small watersheds, they don't have much space for a whole lot of non-tidal streams to go meandering through. Generally, the water will flush off of the land and straight into the rivers or the creeks. And so that provides less opportunity for any sediments that wind up in the runoff to settle out in non-tidal streams before they reach the tidal stations that we do the monitoring, or that in this case, the Department of Natural Resources does monitoring at. So, you know, as I mentioned when we were looking at the prior slide, there's a lot that might go into what is causing this difference in total suspended solids in the rivers. We're certainly hopeful that with more engagement and interaction with landowners and folks that own the land that is running off into the rivers in South County, that we can try to reverse that unpleasant trend that we see in the West of the highest amount of total suspended sediments and also the lowest 0 amount of underwater grasses. So, you know, this is the sort of work that we're able to do at Arundel Rivers Federation because of the support of the folks that are watching this video, and we're very grateful. And here are some of the things that we have on our plate for 2020. And speaking of support from folks like you, we wanted to urge our supporters, existing and would-be, to become sustaining supporters and sign up to deliver your support in a more predictable way that we can then use to predict our finances a little bit more regularly than you know, one-off donations, which we are still happy to receive as well. But we were really hoping that folks would consider becoming sustaining members. It's very easy to do, and even a couple of bucks a month could really help us out. So if you're interested in becoming a sustaining supporter, please go to arundelrivers.org/donate, and there is an electronic form there that makes it very easy. So thank you all for tuning in to this video. I hope that it's been informative. I also welcome any questions that you may have to either be typed in as comments to the video or directed to me directly. My email is jesse@arundelrivers.org, and you know, I'm always happy to talk with anybody about the data, the report card, the science, any policy issues that you're interested in, and of course, any enforcement issues that you see. If you see something out on the water that doesn't look right to you and you don't know who to talk to about it or whether it's legal or anything like that, please do reach out to us. That is every bit what our job is, and we're happy to do it. So thank you all very much again, and I hope to see you out on the rivers. Take care.